on last Thursday. We got pretty far with our review, so we only have a few more things to cover here. There are two different possible types of applications of linear systems that could show up on the test. And I want to go through an example of each different kind, just so you've seen everything. So here's one type, and the problems would look like this one or very, very much like this one. This is kind of like a weighted, how would I explain this? It's kind of just like in math, we'd call this kind of a weighted linear equation system a little bit, but not that matters. But this is a pretty common kind of question that you'd see for a linear system question. So let's read through this, and then let's see if we can work through the process of dealing with this application, turning all these words into math stuff that we can deal with. It'll help us solve the system. So an auditorium has 750 balcony seats and 1,900 main level seats. If tickets for balcony seats will cost $13 less than tickets for main level seats, what should the prices be for each type of ticket? Now that's important, right? Remember, we go to the question oftentimes to figure out what the variables are, because almost always the question is asking about the unknowns, which are the variables, right? So what should the prices be for each type of ticket so that the total revenue from a sellout performance will be $88,300? Okay, so let's put this together here kind of piece by piece. So first of all, Akira, what are the variables here? What are the unknowns? Now look at the question again. It says, what should the prices be for each type of ticket? So you want to maybe change that slightly? There you go. Good. So the price for each kind of ticket. So we'll let X be the price of the balcony seats, and how about let Y equal the price of the main level seats? Okay. Do you guys know, Akira, do you know what revenue means? Like, what's revenue mean to you when you read that? The revenue from a sellout performance will be $88,300.
I'm not sure.
Anybody know what revenue is? Well, it's similar. So if you're running a business and you want to talk about the revenues from the business, the revenues that's all the money that's coming into the business. The costs, that's the money that you're paying out to run the business. And the profit is going to be the difference between those. Profit is revenue minus cost, right? So it's the amount of money you're taking in minus the amount of money you're spending, tells you how much you get to keep, right? But so all we care about here is revenue. That's a pretty important word in math, though. It's going to show up quite a bit in these applications. So it's one we want to be familiar with. So revenue is the amount of money that we're making as a business from selling something, in this case, from ticket sales. Okay, what's it mean? What's a sellout performance mean? Brogan, what's sellout performance mean?
It means you sold all the tickets.
You sold all the tickets. So in this case, we sold every seat, so we know that there were 750 balcony seats, so we sold that many balcony tickets, and we must have sold 1,900 main level tickets. Okay, so that gives us the ingredients to maybe solve this system. Now, first of all, let's recognize that we have two variables in our system. So how many equations at least do we need to solve this system, Skylar? If I have two unknowns, I need how many equations? Do you remember?
Would it be two?
It's two, exactly. Yeah, you always need at least as many equations as you have unknowns. So we got to come up with two equations here to solve this system. Okay, so let's see if we can do that. What about the sentence not really a sentence, the phrase or the words up there that are underlined in red? If tickets for balcony seats will cost $13 less than tickets for main level seats, what does that mean in terms of an equation? Now, a lot of times it's best to take these words the way they're written and see if we can maybe rewrite them in a simpler way. If you can ever integrate the words is or are or something like that, if you can use, something is or a different form of the verb is, that's great because that means equals, right? So Aurelia, would you agree that we could maybe say, like, tickets for balcony seats will cost 13 less than tickets for main level seats? Maybe I could make that simpler by saying balcony ticket price is 13 less than main level ticket price. Isn't it easier to think about it that way? Balcony tickets are 13 less than main level tickets. See if you can turn that into an equation. Keeping in mind that X is the price, that stands for the price of balcony seats, and we defined Y as the price of main level seats.
So balcony seats are less X
Okay, so X
equals
equals, very good.
I'm getting the X and Y mixed up. So
Well,
balcony tickets are going to be less. So X equals Y plus 13.
it says that balcony seats will cost $13 less than main level seats. So balcony ticket minus 13, isn't it? Right? Because the balcony ticket is X, balcony tickets are, so that means equals $13 less than main level tickets. Well, that's just 13 less than main level tickets. Main level tickets price is Y. So that's just Y minus 13, right? Everybody see that? See how we can kind of make that transition there into math? And so there's our first equation, right? First equation we get is X equals Y minus 13. Okay, what about the next one? The total revenue from a sellout performance will be $88,300. Emily, how about that one? So total revenue is $88,300, right? We could maybe make that a little simpler. Total revenue, so that's the money from the balcony seats plus the money from the main level seats, is $88,300. How could I represent the revenue, the money from the balcony seats and the money from the main level seats? X is the price of balcony seats and Y is the price of main level seats. What do you think, Emily?
X plus Y equals 88,300.
Say that again, I'm sorry.
Would it be X plus Y equals 88,300?
Okay, so X is the price of an individual balcony seat, right? And Y is the price of an individual main level seat. That's what we mean by that up there. Now keep in mind, if it's a sellout performance, we're selling all the tickets, and there's 750 balcony tickets sold then, right? Because there's that many seats, and there's 1,900 main level tickets. So you want to maybe adjust that answer just a little bit? What would the money from all of the balcony seats be if each balcony seat costs X dollars and we're selling 750 of them? Emily?
750.
750 X, right? Does that make sense? 750 seats times X dollars for each seat. Okay. Good. So what do you think then, Jordan? Can you finish that for us then? That's the money from the balcony seats is 750X. What's going to be the money from the main level seats if there are 1,900 of those and each one costs Y dollars?
700 plus 1,900 Y equals 88,300.
There you go. Very good. Outstanding. So there's our second equation, right? And now all we have to do here, remember, this is the part of the test we're on now. These are the practice problems that are going to have access to a Desmos graphing utility, right? You're going to get the Desmos graphing calculator on this. And so we could just, there we go. So we could just graph this system, right? And let Desmos find the solution for us. Man, I always do that. So there's my system, right? There's the red equation. There's the blue equation. In Desmos, I do not have to put these in slope-intercept form, right? I can just type them any form I want. All I have to do here is just zoom out until I can see the intersection. And where is the solution, Mr. Weller? Where is the solution going to be on the graph? Where's the solution? Where do I find the solution of this system? Questions to James Weller. Whoops. No James. How about Jade? Oh, there we go. Isn't working. That's fine. So I'm going to skip you then, James. Jade, where would I look for the solution of the system on that graph that we just created in Desmos? Questions for Jade? Jade, are you out there? Okay, so we're solving this system, right? But we're using Desmos. So I graphed these equations in Desmos, and I want to use Desmos to get the solution of this system. What do? I got these things graphed. Where would I look to find the solution in Desmos for that linear system? There's the graph of the red line. There's the equation for the graph of the blue line. Where do I look on this graph?
Where they intersect.
Yeah, where they intersect. How about that? Where they intersect right there. Okay. Well, let's get a picture for our notes. So, what do you think here, Chavino? What's the price of the balcony seats then, based on that solution?
24.
Yeah, very good. $24. Good. Because we know we defined. Remember, we said X is the price of the balcony seats, right? So there's my X coordinate is 24. And then I bet you're going to tell me that the price of the regular or the main level seats is 37, and you're correct. Okay, good. Give me 1 to 5, everybody, real quick. Make sure you're typing it in if you're not showing me fingers. Quickly. Okay. All right. Boy, that's pretty good for a big application like this. All right. I like it. Okay, next one. This is the other kind of application problem that you could see. This would be like a perimeter type problem. So a landscaper plans to dig a rectangular garden whose length is to be 2 feet more than the width. If the landscaper has 36 feet of fencing to enclose the garden, what should the dimensions of the garden be? So they're asking about the dimensions. So in this case, what does that mean? Let's see, Alara, what does that mean our X and Y are going to represent? The length and the width, exactly. And it doesn't matter which one you call X and which one you call Y. As long as you stay the same the whole time, it doesn't matter. Well, I called X the width and Y the length, but you could have switched those. It would have been fine. Okay, so if we're saying X is width and Y is length, then now we got to come up with 2 equations to solve for those 2 unknowns, right? So what about the red information up there? we know that the length of the garden is 2 feet more than the width. So we could make that an easier sentence by saying length is 2 more than width, right? Length is 2 more than width. So if we do that, Savannah, what would maybe that first equation up there be? The red equation.
I'm not sure.
So length is 2 more than width. Is means equals, right? So what's length, X or Y?
Why?
Y, okay. Oh, you know what? I don't know how I got, that's supposed to be length, not, let me fix that. Whoops. I just kind of cut and paste here, and I didn't finish the job, did I? Okay, that's supposed to be, this will help. So that's supposed to be length. So length, oh, you guys ever just, isn't this just kind of a comedy of errors up here sometimes? Length Y is equals, so we got Y equals 2 feet more than the width. So what do you think? Savannah, how am I going to say 2 feet more than the width, 2 more than the width, if the width is X? What's that going to look like?
I don't know.
The width is X, and we want 2 more than the width. So 2 more than X would be what? I bet you got it.
I really don't. I'm confused.
Okay, that's fine. That's fine. I'm sorry. I didn't mean to be picking on you. No, you're good. Olivia, help her out.
2x.
2 times X?
Yeah.
2 feet. We say 2 more than the width would be 2 times X. So what if I said, what's 2 more than 7? 2 more than 7? What's 2 more than 7? Like if I've got $7 and you've got 2 more dollars than I do, you don't have 14. What do you have? 9. There you go. Okay. So I'm not multiplying by 2. What am I doing? Adding 2. There we go. So we get X plus 2, don't we? So the length Y is equals 2 more than the width, X plus 2. So there's our first equation. Y equals X plus 2. Okay. What about the second part here? If the landscaper has 36 feet of fencing to enclose the garden. Okay, Mr. Thatcher, help me out with that one. 36 feet of fencing to enclose the garden. What does that mean if we're enclosing the garden with fencing? What does that sound like for that rectangle we're talking about? The perimeter. Yeah, good. We're just saying that the perimeter is what?
36.
36. Okay, now how do we say perimeter in math? If x is the width and y is the length, what would perimeter be then?
X plus Y plus Y.
Okay, another way of saying that would be 2x plus 2y, right? Good. And we need 2 widths. If we're going to go all the way around the rectangle, we're going to walk the width twice and we're going to walk the length twice, aren't we? So we get 2 x's and 2 y's, and that must equal 36. Very good. And so there's our system. And this is an easy enough one that we could easily solve this algebraically, but why do that when we've got access to the calculator here? So we'll graph this system. There's our system. We graph both of those lines and we're just looking for the intersection, right? And so here's our intersection at 8:10. Okay, so then let's interpret this result. Let's see here. Who am I talked to? Lindsay. What's the width?
8.
8. There you go. And the length?
10.
10. There you go. Width 8 feet, length 10 feet. Very good. Okay, give me 1 to 5 on that one. Type it in real quick. Okay. All right. So these are tougher, right? There's no doubt about it. Application problems are just a little bit tougher. And the hard part is not the math. You have access to Desmos for that. It's setting up those equations, right? So this video it's already available, this video, the second part of our review. I would strongly encourage you, when you're going through the review assignment, if this stuff, if you're not feeling really confident, maybe go back between now and the test, go back and maybe take another look at this video and just look at the examples here that deal with these applications and just kind of walk through them step by step while maybe you're doing some practice problems. It's always a good way to study. And then of course I'll be here after school too if you have questions on things after school. Okay, how about this? We've got, let me look at something real quick here. Okay, never mind. Just want to see where we were. Okay, is the ordered pair 4/7 0 a solution of the inequality? Let's see, McKenna, how would you go about doing that one?
Would you plug in the values for both of them into the equation?
Yeah, into the inequality? Yep, you bet. We could just plug those into the inequality and just in Desmos, and we could even just use Desmos Scientific, right? We wouldn't even have to have the fancy graphing one. If I plug 4/7 in for X and 0 in for Y, and remember, I always want to enclose those values in parentheses when I'm making a substitution like that, then I end up getting the value on the left side, 2.857, blah, 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 blah. I get some big decimal that is greater than 2, right? So it makes it a true inequality. So yes, it is a solution because it satisfied the inequality, meaning it made it true. Okay, another way we could do this one, being as we have the graphing utility available, is we could just graph the inequality, right? 5x plus y is greater than 2, and it gives us the graphed inequality, and graph the ordered pair and see if the ordered pair is in the shaded region. How do you graph an ordered pair in Desmos? Exactly like you'd expect. You just use parentheses, and you type two numbers separated by a comma, just the way it looks. And if I graph that ordered pair, what do we see? Well, we see that point is in the shaded region, so it must be a solution, right? Either way you want to do it, it works. Okay, what about this guy? They give us a graph, and you're asked to write the linear inequality corresponding to that graph. So, Melinda, we got to come up with an inequality here. That always starts with the boundary line, doesn't it? Okay, so by inspection, we'd say in math, by just inspecting the graph, can you give me the pieces of a linear inequality in slope-intercept form? Could you tell me what the y-intercept is?
The y-intercept is 3.
It is, right? I know b is 3. Could you tell me the slope?
With the slope, would it just be 1 because it's 3 over 3, but that just equals 1. Right?
Okay, is it 3 over 3? Is it positive 3 over 3? Negative 3 over 3. Good. So it ends up being -1, doesn't it? You're right. So does everybody see how we got that? I've got these 2 points, and we'll just make a slope triangle. That's what Melinda was doing. We rise by -3, and we run by 3. So my slope is -3 over 3, which just becomes simplifies to -1. Very good. And we are notice that we are shading below, right? So we got these three ingredients here. We know B, we know M, and we're shading below a solid boundary line. So what do you think? What are we going to get for our final answer then? What's all that stuff going to add up to tell us about this? Let's see here. How about Tony?
You want me to give the whole inequality?
Yeah.
Okay, so would it be y is less than or equal to negative 1 plus 3?
Negative
1 plus 3.
Negative 1x, right?
Negative 1x, yeah. Sorry.
Negative 1x plus 3. There we go. Okay, so, and I need to add, we need to have an equals there, don't we? Because it's a solid boundary line. Now, for our notes, I've color-coded this, so this ought to make good sense here, right? So we know that the y-intercept is b. That's the blue part of our inequality. The slope is the red part. And the fact that we're shading below a solid boundary line is the green part, right? That gives us the inequality part. Okay? Give me 1 to 5. Okay, very good. Graph the solution of linear inequalities. All right, this is no big deal. Take that. That's what we did in our honors class today. It's kind of weird looking stuff, isn't it? Okay, so let's try this out. All we're doing now is we're just going to graph each of these parts in Desmos to find the overlapping region. Remember that we don't even have to solve for y. We don't have to put these in slope-intercept form. So the first part is just going to be 2x plus y is less than or equal to 8. So that makes sense, right? We've got a solid boundary line. If we solve for y, I end up with y is less than or equal to something, so I'm shading below, right? Okay, so there's the first part. What about the second part? X is greater than or equal to negative 4. What's that boundary line going to look like there? I want to know, what's the boundary line going to look like? The boundary line is just going to be the line x equals negative 4. Describe that one to me. Let's see, Jordan? Solid vertical line. Very good. It's vertical and it goes through negative 4, doesn't it? So we get x is greater than or equal to negative 4. And sure enough, there's our boundary line, right? A solid vertical boundary line. And we want the x values to the right of our boundary line because we want the x values that are greater than negative 4. On the x-axis, greater means to the right, doesn't it? The bigger the number, the further to the right it is. Very good. So there's our second one. And then finally, what about y is less than 2? Akira, y is less than or equal to 2. What's that boundary line look like? What's the boundary line y equals 2? There you go. So I'm getting a horizontal line less than or equal to 2. Looks just like that. I'm going to change the color here a little bit. There we go. So I get my solid horizontal line, y equals 2, and I'm shading everything below that because I want the y values that are less than my boundary line. And if I turn all three of those on at the same time, this is what it looks like. It's not very pretty looking color down there, but I don't even know what you'd call that, but that's our triple shaded region. That's the only part that is shaded by all three of those inequalities, right? So that is our solution. Okay. And last one. So for the last problem, oh yeah, here we go. So this is just an application of linear inequalities is all, right? So we want to see if we can build an inequality here that's going to represent this situation. So a freight elevator has a capacity of 4,000 pounds. If a barrel averages 40 pounds and a crate averages 160 pounds, it says write an inequality that describes when X barrels and Y crates will cause the elevator to be overloaded. So they're not asking for the ones that the elevator could carry. They're asking for the different combinations that would overload the elevator. Okay, so we got to come up with this inequality. So we need to be able to represent, how could we represent, well, what are X and Y, I guess, first of all? I always want to start with that. They tell us, don't they? They tell us right here. They tell us that X represents X barrels. So X is the number of barrels. And Y is the number of crates. So the amount that the elevator can carry, we're supposed to figure out the values of X and Y. They're going to cause the elevator to be overloaded so that the amount of weight we're putting in the elevator is what relative to 4,000? What do you think, Emily? If we want to overload the elevator, what's our inequality going to look like here maybe? Greater than 4,000. Good. So we're going to come up with some expression here for the amount of weight we're loading in the elevator. We want to know, when is that greater than 4,000? Okay, so what about the first part of that? We need to come up with an expression that predicts the weight of X barrels and Y crates. What do you think about that one? Let's see, McKenna.
Would you do 40x plus 160y is less than or equal to 4,000 pounds?
But we said greater than because we're overloading it, right?
Oh.
Yeah, but you had the right idea, right? So there we go. So the cargo weight, which would be 40x plus 160y, overloading the elevator means, when is that greater than 4,000? Okay, and so if we wanted to look at a graph of that, it just looks like that, doesn't it? There it is. There's our graph. So those are all those infinite X values there, X and Y values, those ordered pairs in the shaded region. Those are all the different combinations of X and Y that are going to overload the elevator. And I guess we probably should add a couple more things, right? Because X and Y, if those are the number of barrels and the number of crates, they can't be negative, can they? Right. So once again, this goes back to that discussion we had earlier. We probably need to say something like X is greater than or equal to 0, and Y is greater than or equal to 0. And then we get something like that, don't we? So now it's only this region up here. So any point in that region up there is going to represent a value of X and Y that would overload the elevator. Does that make sense, everybody? Okay. All right, I'll get a picture of that. And I am going to let you work. I don't know how much time we got here, but a little bit. So you got about 10 minutes here where you can just work on this stuff and get questions answered if you have them.